Okay guys, so now it's time to review chapter 5. So chapter 5 was where we learned a lot about the periodic table, and we started learning about things like moles and molar mass. So that's going to be the main thing we need to review. But let's just talk a little bit about valence electrons really quickly. So remember, when you look at the periodic table, you can tell how many valence electrons any element has by looking at what column it's in. So everything in this column has one valence electron. Everything in this column has 2. We skip over this section. 3, 4, 5, 6, 7, 8. And you want to remember the elements that are in the same column are similar to each other because they have the same number of valence electrons. So for example, lithium and sodium and potassium all react in a similar way. They're all pretty explosive with water because they all have just one valence electron. So that's an important thing to remember. So the answer to that is that they are the outermost electrons in an atom. They're the ones in the outer energy level, and they determine how a chemical reacts. Okay, so you need to be able to calculate the molar mass of any given molecule or formula unit. So the molar mass is the mass of 1 mole of a substance. So this question is asking, if I have 1 mole of aluminum nitrate, because that's what this compound is, if I have 1 mole of aluminum nitrate, how much does that mass? How much does it weigh? Even though mass isn't exactly weight, what is its mass? So what we need to do is we need to look up the molar mass of each individual element that's in that formula, and we have to add them all together. So we've got 1 aluminum in there, and aluminum is 26.98. And then this 3 outside the parentheses, that distributes in to the oxygen and the nitrogen. So I have 3 nitrogen, and it has a molar mass of 14.01. And then I'm going to actually have 9 oxygen, because 3 times 3 is 9. And oxygen, if you look on the periodic table, is 16. All right, and then you have to add all of this up. So if you want to just be really safe, you can multiply these out individually. So if we go 3 times 14.01, that's 42.03. So we got 26.98 plus 42.03 plus 9 times 16 is 144. And then I just need to add those all together. So 26.98 plus 42.03 plus 144. I just did that on my calculator. I got 213.01. And then the units of molar mass are grams per 1 mole. So that's the molar mass. You could also see it written as 213.01 grams per mole, like grams / moles. Same thing. Okay. Last thing you need to be able to do is use this moles to grams to molecules chart to solve problems. So this problem says how many molecules are in 5 grams of CH4. So it's giving me grams. So I know that I'm starting in this circle with grams. And it's asking me for molecules. So I know I'm trying to get to here. So I know I need my given plus this conversion factor and this conversion factor. So I'm just going to start with my given. Nothing down here. Or you can just put a 1 down there if you want to. And then I need to use the molar mass of CH4 to cancel out grams. So I happen to know that carbon, if you look it up on the periodic table, has a molar mass of 12.01, and hydrogen is about 1.01. So that's going to end up being about 16.05 grams of CH4 over 1 mole of CH4. So 16.05 grams of CH4 is going to go on the bottom so that grams of CH4 will cross out. And I'll have 1 mole of CH4 on the top. And then to get to molecules, I'm going to have 1 mole of CH4 down here and then 6.02 times 10 to the 23rd molecules of CH4 up here. So my moles cross out, and then I kind of ran out of space here, but I would multiply everything on the top. So I would type in my calculator. I'm going to turn it to the side so I have all my extra buttons. 5 times 6.02 E, 23. Sorry, am I texting notifications? Okay, 3.01 times 10 to the 24th. Molecules. And then that's still over 16.05. So I need to divide by 16.05. So that's going to be 1.88, we'll round that, times 10 to the 23rd. So don't forget, this E means times 10 to the 23rd molecules of CH4. Now, one last thing that they can do on questions like this that can be kind of tricky. This question asked for molecules of CH4, but if it had asked how many hydrogen atoms are in 5 grams of CH4, I would have to take one more step. So this is how many molecules I have. How many hydrogen atoms are in each of these molecules? Well, there's 4 hydrogen atoms in each CH4 molecule, right? Because of that little subscript 4. So to find the number of hydrogen atoms, I would multiply this number by 4 if there was a question like that. And that would tell me how many individual hydrogen atoms there are. So just be careful about what the question is asking for. If it's asking for molecules, you're done there. If it's asking for the number of a specific atom, then you might need to multiply by something else. So we would have 7.50 times 10 to the 23rd hydrogen atoms. So 4 times as many hydrogen atoms as CH4 molecules. Hopefully that makes sense. If you have questions, let me know. But you guys got this. We've done lots of conversions like this. You can do this.